Hello class, this is a video tutorial on quadratic functions. In this video we'll be looking at the general equation of a parabola. Well, the general equation of a parabola is as follows. Y equals ax squared plus bx plus c. When graphed out, it looks like the following, like so. And its key features that we need to know are the vertex. I've marked it here in orange. The vertex is the highest or lowest point of the parabola. In this case, it's right here. The axis of symmetry is, what's this called? Is where the vertex is found. In this case, the axis of symmetry at this point here. It has the x-intercepts. It has at most 2 x-intercepts. X-intercept meaning that the graph crosses, right? It crosses the x-axis at one point here, and it crosses one more time here. It crosses the y-intercept here, and we have this one last thing about concavity. We'll look at that in this little section here. The concavity of a parabola is determined by the value of a in the equation. So this value here determines the concavity of the parabola. If a is positive, the graph will be concave up. So in this case, the value of a is half. Half is positive, so the graph has a concavity that is up. A nice and easy way to remember this. It's positive, so it's smiley. If a is negative, so this value here in front of the x squared, in this example it's negative 2x squared. So because it has a negative value of a, well, then the graph is concave down. Another way to remember this, if it's negative, it's frowning. If the parabola is concave up, its vertex is referred to as a minimum. So this is the vertex of this parabola. However, because it is concave up, its vertex is referred to more specifically as its minimum. Minimum. The reason for this is because it is the lowest point of this graph. Alternatively, if the parabola is concave down, like here, its vertex is referred to as the maximum. So here's the vertex, and because it's concave down, that is the maximum. Okay, so let's do an example of how to find these in these graphs. So for this, let's determine the following. Let's determine from the easiest to the hardest parts to determine. Let's find the y-intercept. The y-intercept is very easily found by looking at the y-axis, this line here, and see where the curve crosses the line. So in this case, it goes past at that point there. So the y-intercept is at 0, negative 10. Let's do the x-intercepts. The x-intercepts are where the graph crosses the x-axis, sorry. So here's the x-axis. And this line, this graph crosses at 2 points, one here and one there. So the x-intercepts, there are 2. Let's label them. The first one is at 2, 0. And the next one is at 5, 0. Okay. Let's now do the concavity of this. Well, it's very obvious because it's going downward, it's frowny. We can say this is concave down. Its vertex, more specifically, its maximum. Its maximum is at the coordinates. We can see it's right about here. We can approximate where it is. There it is there. It seems to be exactly halfway between 2 and 5. Okay, and let's also take a look at its y value, sorry. So round about there. Okay, so let's figure out the values of that y axis here. So each point is about, sorry, I deleted that there. Each point is about 0.2, 1.2, 1.4, 1.6, 1.8, 2. Okay, so each jump is about 1.2. So that's 2.2. From the looks of it, that is about 2.3. Okay, so this maximum, because its vertex is now a maximum point, is at this value here, this x value. That looks like it's about 3.5. Its maximum is at 3.5 in the x coordinate, and its y coordinate looks about 2.3 from the looks of it. Oops. And lastly, we have its y axis of symmetry. Its axis of symmetry is exactly where the vertex is. Okay, there it is. And we can label that as the same x value as the vertex. So its axis of symmetry is at x is equal to 3.5. And these are all the key points that we mentioned in the previous, in the beginning of this video. So I'll be doing these next 3 examples in the next video. Hope this gave you an insight into the key features of a parabola. Hope to see you in the next video. Best of luck.